So what we're going to do today is we're actually going to go through the practice assessment, and I'm going to talk about how to go and solve every single one of the angles on it. So we're going to go through the whole thing together as a group. If you haven't finished it already, what I would strongly recommend doing is going and working on this on your own instead of watching me do it, and then watch the recording to check your answers a little bit later. This is almost exactly what the quiz tomorrow is going to be, but the quiz tomorrow is going to have more questions with a little bit more difficulty and a few more of the rules. So let me get this open really quick. Okay. So if you haven't done this yet and you want to take off and go work on it on your own, I have all of you that are here marked down. However, if you leave class and then don't turn it in by the end of class today, I'm going to mark you as absent. So don't just leave and don't do anything. If you want to just stay and watch how it's done so you can kind of take notes or see how each question gets solved so that you can practice it that way, that's fine. Totally up to you. But like I said, if you want to practice this on your own and then watch the recording later, that might not be a terrible idea. But we'll go ahead and get started with the first one. So the first thing that I want to say about all of these things is don't necessarily go in order when you're solving these. In general, the letters and numbers that are put on here are kind of put in order of where it makes sense to put them when you're making it, not in order of where it makes sense to solve them. So for instance, when you get down to H, this is not the one you should solve in this order. And then it goes to UVT. That's because you kind of work your way down here. So don't go in order is the first thing that I would suggest. For instance, easiest angle to solve right now is probably B, not A. A is not terribly difficult either, but B and 45 degrees have a relationship. What is that relationship? Can anybody tell me? Are they supplementary, vertical, or complementary?
Complementary.
They are technically complementary. But that's not the one I'm looking for. So they're formed as opposites of two vertical intersecting lines. Is that vertical, is that supplementary, or is that complementary? Yeah, Dane. So good, it's vertical. So if they're vertical angles, that means that they have the same measure, which means we can immediately put in that B is 45 degrees. So that's probably the easiest one to solve. You'll notice that A was put here. That's the first one. So you can also solve A pretty easily. What is the relationship between A and this 45-degree angle? Can anybody tell me that one? Good, Pamela. So yeah, Pamela said they are supplementary, and that is correct. So they're supplementary angles. Together, they form a half circle or a straight line. So in order to solve for A, we would take 180, because that's our supplementary angle rule, subtract our 45, and we get 135. So this is 135 degrees. And then what about C? C has a relationship with A that makes them very easy to fill in. Can anybody tell me what that is? Vertical, complementary, supplementary. Pamela got it. Looking for somebody else to answer a question. Dane also got it. I'm getting the same two people every time. It's a little concerning, but all right. So this one is 135 degrees as well. Again, it's a vertical angle, so that means that A and C are congruent. Now, moving on, we can do the same idea with the 110. We could fill in these ones next if we wanted to. We could also potentially move down to D, E, F, and G, and I'm going to go ahead and do that. So D, E, F, and G have a special relationship with A, B, C, and D. Can anybody tell me what this line here is called? One that I'm kind of highlighting, but doing a really bad job of. It's got a special name. Does anybody remember what that is? Well, my drawing of it, Brennan, was a non-straight line, but the line itself is straight. And Barb, that's correct, but
is it the point of intersection?
It's not the point of intersection. So we've got these two parallel lines here. The line that goes across from the top, and then the line that goes across is the second one going straight across. So what's that line that intersects both of them called? Does anybody remember? On laser pointer. So if this line and this line are parallel, and this line cuts them both, does anybody remember what that's called? It's a funny word, starts with a T. You should all have it in your notes.
Translucent?
Close. It starts with trans, but it's transversal. So this is a transversal of two parallel lines. Because it's a transversal of two parallel lines, that means these hit at the same angle. So if they hit at the same angle, can anybody tell me what the angle on D is? Correct, Jocelyn. So 45 degrees. So A and D, or sorry, not A and D, D and this 45-degree angle that you're given are congruent. They hit at the same angle, so this transversal intersects both of these at the same angle, which actually means that all of these angles, so D, E, F, and G, are congruent to the 45, the A, B, and C. So we can just fill these in as the same as the ones up there. 135, 135, and 45. Okay. There's one other set that is also on a parallel line that is cut by this transversal. Can anybody tell me which angles those are? So this is getting cluttered, hard to read. So I'm going to do some erasing. I'll fill these back in a second. Can anybody tell me what other angles are the same, intersected by that transversal on parallel lines? Oh, whoops.
There, okay.
Yep, I put them backwards. That was my bad. Honestly, let's just clear this again. Start that over. Yes, Pamela, that's correct. So it is P, S, Q, and R have the same thing. So once again, this same line coming through, and this line is parallel to this line, is parallel to this line. So these angles are going to be the same as well. So we've got 45, 135, 45, 135, 45, 135, 45, and 135. Okay, so now we're done with all the angles that we can do just using this 45-degree angle to start out. So let's go ahead and move on to our other given angle, the 110 degrees. Todd, you already turned it in. So 110 degrees, let's look at J to start. What is the relationship between 110 degrees and J? Complementary, supplementary, or vertical? Somebody that isn't Pamela or Dane. Thank you, Pamela and Dane. Come on, everybody. There are like 15 of you. So it's not supplementary. We're looking at J and 110. It's not complementary, which kind of narrows it down. They're vertical, so they're opposite, right? These are two intersections of lines, so they're opposite angles, which means that they are supplementary. So this one, or not supplementary, vertical. So they're congruent. So we've got the 110, J is also 110. Then let's look at I and the 110. So what's the relationship between these ones? Complementary, supplementary, or that's correct, Todd, but what's the relationship? Are they complementary, supplementary, or vertical? Carter, that is also correct, but why? Nope, they're not vertical this time. I and K are vertical, so I and K are going to be the same. Right, so what relationship is that, Carter? Supplementary, complementary, or vertical? Todd, that's correct. So these are supplementary. Again, they form a straight line when you combine them together. So we've got that I and the 110. If they form a 180-degree angle together, we can just subtract. So we're going to take 180 degrees minus the 110, and that will give us 70 degrees for I. So I is 70 and K is 70. Now, we got to be really careful here. With this last one, we could just fill in other angles by saying, okay, well, this transversal is cutting these congruent lines, or these parallel lines, but there's no line parallel to this segment that's cutting the first three, and there's no line that's parallel to the segment that's cutting the other way. So neither this line nor this line have any parallels, so we can't just fill in any other angles that easily. What we have to do instead is now look at H. So G, H, and I together all form a triangle. And we know that the measure of all the angles combined in a triangle is 180 degrees. That means that 180 degrees, 180 degrees, minus the measure of G, which is 45, minus the measure of I, which is 70, will give us the measure of H. 45 and 75 combined to 115. So we can do 180 minus 115, and that's going to give us 65 degrees for our angle for H. So H is 65 degrees. What is the relationship between H and V? Can anybody tell me that one? Good, Pamela. Good, Todd. So these two, again, because they're on opposite sides of an intersection of lines, these are vertical angles, which means that this one is congruent, so it's also 65 degrees. What about the relationship between H and U? Complementary, supplementary, or vertical? Correct, Pamela. Correct, Todd. So these two, again, since they form a straight line, when we combine them, they are supplementary. So we take our 180 minus our 65, and we get 115 is the measure of U. So this is 115. What's the relationship between U and T? They're on opposite sides of an intersection, so they are also vertical, which means that this one is congruent again. So U and T are the same. We've got a 115. Now, if we look at this line that starts here and ends here, I don't want to draw all over the middle of this because it's already really cluttered. We've got, it intersects 3 different parallel lines, including this one here. So what's the relationship between H, T, U, and V, and W, X, Y, and Z? Or I guess, what are the measures of H and W relevant to each other? I feel like maybe that was too confusing of a question. So because this line right here is intersecting these 2 parallels again, it's another transversal. And again, transversals hit parallel lines at the same angles. So we can just kind of take these 4 angles and move them up here, which means our Z is still 65, our W is 65, our Y is 115, and our X is 115. And then we can do the same thing in the bottom left, and then we're done. So 65 here, 65 here, 115 here, and 115 here. So that's how we solve for all of the angles in this one. None of them are too terribly difficult individually. The biggest or the toughest part of this one was getting this H. That's going to be the most difficult angle on this specific one. The one you're going to get tomorrow is going to have a few more lines and a few more angles for you to fill in. So make sure you feel comfortable with these relationships before you move on to that. I'm not going to go over and fill them all in here just because that'll take a little bit too long, but I can put up an answer key in the Google Classroom so you all have it. But really quickly, let's go into this one. So the first question, why are these 1, 1, and 1? They should be 1, 2, and 3, whatever. The first question says list 2 angles that are complementary. Now, we don't have any angles back in our drawing that form up to make a right angle anywhere. There's nothing that looks like this. But we do have 2 angles with measures that add up to 45 degrees. Can anybody find, or sorry, angles with measures that add up to 90 degrees? Can anybody find 2 different angles that their measures combined are 90 degrees? Todd, that works. Dane, that works. So Todd said P and R. So you'll notice the measure of P is 45. The measure of R is 45. 45 plus 45 equals 90. Dane said B and D. That's this one and this one, which are also 45 and 45. Pamela said D and G, which is 45 and 45. Barb said R and A. I think she meant this one though, or R and B. But basically, you can pick any of the 2 45-degree angle ones, and they'll work. So you could do the initial angle that's given in B. I don't know how you'd label this one. D and G, G and R, G and P, whatever you want to do. So the complementary ones, any of those will work. But I will go ahead and say P and R, since that's the first one that I got. List 2 angles that are supplementary. So that one should be a little bit easier. We can really just look at any pair of angles that form a straight line. So you could do Y and Z are supplementary, W and X are supplementary, Z and X are supplementary, Y and W are supplementary. Same with all the other intersections, I and J, K and J, P and Q, R and S, Q and R, S and P. You guys get the point, I think. Pretty much any ones that you can draw a half circle on that form a straight line when you combine them together are supplementary. I'll go ahead and use, sure, why not, Y and W. Please tell me those actually work, Todd. They do. Okay, cool. So yeah, Y and W work. And then 2 angles that are congruent. So this one, you also have a whole lot of options. You could pick any of the ones with a measure of 115, any of the measures with 45 or 135. The 2 with 65, the 2 with 70, the 110s, whichever ones you want to pick. It doesn't really matter here. So I'll just go ahead and say A and C. But there are a whole lot of options for all of these. Okay, so that is the entirety of the practice assessment. That's how you solve for all of the different angles here. If you're still confused about how to do this, please stick around. Barb or me or potentially Jenny would be happy to help you. We can help you work through the practice assessment on your own, or we can try to give you some more example problems. But tomorrow we're going to be doing the actual assessment, which is basically going to be the exact same thing. You'll have all day in class to work on it. So make sure that you know how to do this before then. And make sure you've turned in your practice assessment if you hadn't already. But yeah, otherwise we're done for today. There is no new homework. Just make sure you have the assignments done for this chapter so that you're ready for the test tomorrow. And you guys are good.